Okay, so recently I've been making a lot of videos about agents and doing things with various agents. And I've also been in San Francisco meeting with a lot of startups who are doing things with agents. And one of the things that I'm seeing, which I think is one of the most interesting things, is actually people doing agents with multimodality. So basically multimodal agents. And to do that, you're basically going to be either doing some sort of analysis of images or of audio is what most people are doing now. Recently at Google I/O, Google launched PaliGemma. I mentioned this in the videos about Google I/O, and I mentioned that I'd come back and make a video about it. So I'm going to talk about PaliGemma, but I want you to think as we're going through this, how could you use this in agents? Because it's certainly something that you can use for a variety of different tasks in here. So first off, what is PaliGemma? So PaliGemma is a VLM, or a vision language model. So this is basically where we can input both an image and some text and then get something out. In this case, it's going to be text that we're getting out here. So the PaliGemma is basically a sort of smaller or slightly modified version of a PaLI-3 paper that Google put out last year. And this is basically using a Gemma 2B as a text encoder combined with a SigLIP model, which is going to be the image encoder here. Now, if you're interested in finding out more about these, this is the original paper for SigLIP for doing it, and along with the PaLI-3 vision paper to go through this. There's a really good blog post that's been made by the Hugging Face team. And I think some of the people on the Big Vision team from Google have also been involved in this. And this basically goes through and shows you a lot about what actually PaliGemma is, what Google's actually released, how you can actually use the models and stuff like that. And we can also have a quick look at how you would actually fine-tune the models. So the key understanding with these vision language models is that usually you end up using a pre-made image encoder. And this particular image encoder is SigLIP. So another very famous one is CLIP, which is used in Stable Diffusion, is used in a bunch of other things. So the SigLIP vision encoder in many ways is very similar. It's just using a sigmoid loss though. The other key part of this is the text encoder, which obviously we're going to need something going through there. And what is commonly done, and this, if we go back to sort of models like Blip last year from Salesforce, Mini GPT earlier in the year, is that people train this linear projection layer that sort of goes through from the image encoder, projecting it through to basically match what your language model is. So in this case, we're using Gemma as the language model. So we've got the original SigLIP image encoder. Going through this projection layer, we're going to put the text in as well, match these up. And you can think about it as like we've got a certain number of tokens that are going to be used for representing the image. And then we're going to have some tokens that basically query that image in here. Now, Google and Hugging Face have released a bunch of different models for this. So you've got these pre-trained checkpoints that they've released. And these are really sort of made more for fine-tuning on downstream tasks and stuff like that. They've also got mixed checkpoints, which can do general visual question answering, things like that. And then they've also released some sort of academic checkpoints, which are more based purely on fine-tunes of very specific academic data sets and stuff like that. So there are a number of different models in here. The other things too is that the input sizes for the images are different as well. So when you put an image into these things, it gets resized. And sort of the standard ImageNet resizing would be something like 224 by 224. And that's what they have as like the low model here. But they also have two higher resolutions. So a 448 by 448 and an 896 by 896. So in theory, if you want something with a lot of detail, you're going to go for the bigger model that can do a bigger image. But obviously, that's also going to be slower. You've got this trade-off of deciding what you want to do and stuff like that. In theory, the bigger model should be better at certain things like OCR, at picking up very small things in images, that kind of thing in here. But actually, from me playing around with it, the sort of just base 224 by 224 seems to work pretty well for a lot of different things. And then the other thing you should remember too is that if you've got a really specific use of this, for example, if you wanted to process receipts or you wanted to do something really specific, maybe count the number of planes in an image or something like that, you really want to fine tune the models for that particular task. And we'll have a brief look at the end of how you could do that as well. On top of the different sizes that have been released in here, they've also released JAX versions of these. So you can actually run this and do fine tuning on GPUs with PyTorch, etc. But you can also do it natively in JAX on TPUs. And with a lot more of the TPUs becoming more generally available, it makes it easier if you actually wanted to do like a reasonably large data set to fine tune this for a very specific use kind of thing. So you can see that the PaliGemma release from Google has got quite a number of models. We've got the different size image models in here. We've got the different JAX models and stuff like that in here as well as we go through this. Okay, so on top of them putting out a blog post all about this, they've also put out a Hugging Face Spaces where you can try this out. And we can see that we've got access to the two different kinds of things where we're going to basically get it to do segmentation or detection, or we can get it to do text generation or visual question answering, etc. in here. So let's pick one of these. So here's one in their samples where they say, okay, ask for the password. And you'll see that as we ask for the password, sure enough, we're going to get the right password out is AAEEU. I'm always very suspicious of these, so I always want to try things that they didn't put in there. So if we ask it for the URL, actually it does quite a good job of getting hello.wifi. What about if we ask it for what's the name of the hotel? Okay, so asking it what is the name of the hotel, you can see the inference it's doing here is pretty good. And sure enough, it gets the right name out, the Ashley Hotel West Coast, which we've got up here. So this shows you already that you could use this for a number of different things like analyzing invoices. You're doing a whole bunch of things like this. And up until last year, to do this kind of thing, people would have to use things like OCR models and regions of interest models to find the different things and then run them through OCR. Whereas now we can do this with a lot more generalization. It's easy to just take this model and then ask a variety of different things in here. So it is interesting to look at these things like interpreting graphs and stuff like that. If I ask it, what does this image show? And sure enough, it basically says that, okay, it shows the fine tuning on ImageNet in here. What if I ask it something a lot more, right? Now, it's kind of interesting when I say something like this, what model is best? When I ask it something like this, we can see that I haven't really defined what best is, so it may not know. Actually, in this one, we'd probably say the best is the highest accuracy, which would be the Vision Transformer Large. It's gotten that wrong in here. Okay, so I've uploaded the McDonald's burgers menu in here. And you can see, sure enough, if we come down here and ask it what company's burgers are here, it understands that it's McDonald's. If I ask it something like, what is the most famous burger here? There's nothing on the picture that really tells us that information, yet it's able to come back with Big Mac, which is, I would probably say, is the most famous burger from McDonald's. And this is where it's actually using the knowledge of the language model, not just the actual representation from the image that we've got in here. So this makes it quite nice. So that's like the open way of using it. You can also use it to actually do segmentation. So this is one of their examples. If we say segment cat in here, so we can get it to do segmentation, and you can see that it's doing a very good segmentation of the cat there. Let's try it with the two cats. Okay. Segment cats. How does it do well with it? Again, it's done pretty well with that. Now, I have tried it with other things where it doesn't do as well. So my guess is that obviously pictures of cats are very popular in deep learning. These have been put in there quite a bit, I would say. Whereas things like detecting planes and stuff, it could get a sense of the planes there, but it's not actually giving us good sort of segmentation and detection in there. So in these cases, you really want to fine tune for this. So you can see we did segmentation. If we do detect, we should get bounding boxes out here. And sure enough, we get some nice bounding boxes of the two cats there. So this is another use for doing things. Now, there's some really nice data sets out there that Google released, but were very quiet about the whole sort of release of this. Unfortunately, they didn't release the model for this. So what this actually is ScreenAI, where you can actually get a model to do the same kind of thing. They were doing it with a much smaller model, a T5 in this case, and having it being able to identify things on like an Android screen or on a computer screen and generate out a nice representation of what is on the screen, what is buttons, what are the various things in there. Like we can see the OK button, right? It's identified exactly where that is. Now, if you want to basically make agents that can navigate the web and do things like that, you need something like this to go along with the language model stuff in there. So this is a data set that you could certainly look into doing fine tuning and stuff for this. And I do think that the new Gemini 1.5 update may have been trained a little bit on this data set as well. So let's jump in and have a look at some of the code of running the actual code to do this for the inference. And then we can also go and have a quick look at how you could do fine tuning for this kind of task in here. Okay, so I'm going to be using the Hugging Face notebooks that they put out here. I've modified it a little bit to just change some things, add some things in and stuff like that to make it more convenient for me. Personally, I prefer to actually have the Hugging Face token in secrets rather than having to go and look it up and paste it in there, but I've left that what they had originally in there as well. So the first thing is we're just going to get a picture. So this is from their example of getting a picture of a flower with a bee on it. Once you've basically got the picture, and you can see here that they're just bringing it in as an image and then into a sort of pill image here that they can then pass around. The good thing of this format is that once it comes out, basically it's got the channels all ready to go for putting it into PyTorch, etc. Next up, they're basically bringing in a tokenizer, this PaliGemma for conditional generation, and then the processor. So the processor, and this is going to basically put the image through the encoder so we can pass all of that into the actual model. Now we can see that the model here is the 3 billion, the mix with image sizes of 224 by 224. This is what you would change if you wanted to go to the higher resolution models in here. And you'll see that the processor actually takes in the input text, the input image. We basically can tell it that we want it to convert it to RGB in here. We're going to be returning it back as PyTorch tensors in here. And we're just padding it out for any spare tokens that are in there. We then basically just put that on the device. Up here, we put the question, what is the color of the flower the bee is standing on? And you see now we're passing all of that into the model. And then we're just doing the simple sort of decode. So this processor acts like our tokenizer. You can think of it like that, where it's basically converting the image and then taking those tokens, converting the text to tokens, putting it all into a context window that we can then pass into the model in here. So finally, when we come out, we can just decode out. Because we've just got a batch of one, so we're just going to take the first result out. We're skipping the special tokens just so we don't see the other tokens there. And sure enough, here we can see the text that we put in and the answer pink in there. Now, they've also got it so you can load it as a 4-bit model. This makes the inference faster, that kind of thing. It's very similar to the way that you would use a Hugging Face LLM in here. There's really not a lot of change in here. Again, you've got to get the processor going, setting it up. So when you're just setting up the model, you're basically just telling it that you're going to use the quantization for 4-bit in here as well. Finally, at the end, what I basically did was put together a little function that can do all this for us so that we can just basically throw in an image and throw in a question or something like that, and we can test this out. Now, this one I picked here and I've left in here sort of shows that the model is limited in what it can do. So when I ask it who was the first president, some kid's written that the first president was Getty Images. I thought this was quite funny. When I asked him what is funny about this, you can see that we get here is, sorry, as a base VLM, I'm not trained to answer this question. So we could fine tune it on these kind of things to get it to be better with this. But at the moment, this is, rather simple. I took the burger example that I did in the Hugging Face Spaces, and that worked quite nicely in here as well. So when I asked it what company makes these burgers, it came out with McDonald's in here. So have a play with this and just try out different ideas. Now you've got the other models in here that you can actually try out, for different things. If you want to try other sorts of things out for doing sort of the segmentation, detection, that kind of thing in here. The next one I'm going to go through is an example that Merv put up for doing PaliGemma Finetuning in here. So again, you can do both the previous notebook and this can be done with JAX, and it works very well. The reason why I'm showing these ones here is just because most people, I think, are going to be more comfortable with the Hugging Face library, and most people are not going to be doing the fine-tuning on TPUs. So the TPUs, that you actually can't use the TPUs from Colab. You have to use newer TPUs than that. I think the ones from Kaggle will work if you want to go down that path. But I think for most people, they can just start out by doing like a fine tune here. This has got all the code for also for uploading it to the Hugging Face hub so that you can go through. Basically here, they've got a visual question answering data set. We're just taking a very small amount of that and splitting it. You can actually look at what is in here. I encourage you to sort of look at this because then you can get a sense for my own particular data set that I want to do fine tuning. What would I need to prepare? So you can see in here, we've basically got an image where we can see that the size of the image is 425 by 640. So meaning that it's going to be resized by the processor, the PaliGemma processor and stuff like that. We can see that the question for this is what color is the man in the picture mostly wearing? And we can see the answer is black. So you could actually make up your own data set with things like this. If you wanted to do something that is very domain specific, you could actually try out making just a few hundred examples and doing a fine tune like this. And then you probably find that you get that model to actually be much better at your particular domain that you're going for in here. So again, we've got the processor, just bringing everything in there. One of the really important things in fine-tuning Hugging Face models, or fine-tuning Hugging Face versions of models, I should say, because this is actually a Google model, is the whole thing around making a collate function. So what the collate function basically does is just takes your data set inputs and then just maps to what's going to happen in here. So you can see here, we've got the text coming in, we've got the labels, we've got the images that we're converting to RGB. For this, we've got the tokens basically being put together through the processor. So that's like our tokenizer that's in there. And then in this case, we're converting the tokens to bfloat16, putting it on the device and returning. So this function actually is really important. So if you are going to make your own data set, you want to make sure that you adjust this to fit your data set. If you're calling things differently, like this multiple choice answer, really, we could have called that something different if we wanted to in there. They've got an example, which I've left in for doing like full fine tune. What we're actually going to do is like a QLoRa fine tune in here. So basically just, again, using the bits and bytes library to get the 4 bits, selecting what parts of the model do we want to actually do the training on, or do we want to actually do the LoRa adaptation on. So you can see here, we've got just standard stuff that you would do in a causal LLM or a decoder model in here. We can set up the actual conditional model. You can see that when we actually run this through, we can see that we're only going to be training 0.38% of the total parameters that are in here. Still going to be like 11 million parameters, but it's tiny compared to the whole model that we've got going. We then basically just set up the training arguments. So here we're going for 2 epochs. Some other key things here that you want to be aware of is that setting the batch size and the gradient accumulation steps. Here at our GPU, we can only fit, say, 4 of them. We probably don't want to just do batches of 4. We'd prefer to do batches of 16. So we're going to accumulate the gradients for 4 steps, and then that will be considered one batch. So we would get 4 by 4 there, 16. We can set the learning rate, set the number of logging steps so that it will log out every 100 steps. And we can set the saving steps in here as well. All these are exactly the same as what you would use when you're fine-tuning a Hugging Face version of an LLM model, etc. Set up the trainer. Again, really important that we pass in the collate function that we set up above there. And then we basically just train it. And you can see that it will kick off. And we can see that the loss has gone down. I have, there's really a tiny bit of training just to see that it would actually train and stuff like that in here. And then finally, you can push this to the hub. Now you will need to change this to your name in here. But once you've actually pushed that, you'll see that the model will actually show up in your account on Hugging Face. And then you can actually load this model instead of the other model that we used for doing the inference in. So hopefully this can get you started with this. One of the other reasons that I chose to do the Hugging Face way like this is that people want to take a look at the Phi-3 vision models this coming week as well. And I think it's always good if we can get something where we can basically just make it very easy to swap out different parts of the code to go from one model to another model here. Once you've fine-tuned a model for a particular use case in this, these can become really useful for doing multimodal agents where you've got vision stuff and you're getting an agent to basically query an image to then decide the next step about what it does for something. So this is something that's very interesting to look at going forward. Anyway, so as always, the collabs are in the description. You can try them out. Any comments or any questions, put them in the comments below for this. If you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.